Assuming that you've already cut out your pieces, go ahead and set them to where they look like mine. Our array will be 4, 6, 7, 3, 2, 5, 1. Okay, now that you have that, we're going to do some analysis. So, min index is always going to be the smallest value that we have found so far. Now, in the place of min index is a variable called I. I and min index aren't the same thing. We're going to assume that my left hand is I. Okay? J points at a value, and that's what we use to compare against I. Temp, we will talk about temp whenever we get to it. So what we're going to do is we're going to use J to move through and identify numbers smaller than this, and then use this and temp to swap them. A sorting algorithm is going to sort from least to greatest. Right now, if we look at our array, we can see that it's not sorted at all. It's like 4, 6, 7, 3, 2, 5, 1. So what we'll eventually have is 1, 2, 3, 4, 5, 6, 7. That's the goal anyway. All right, so we're going to start by identifying the two numbers that these guys are pointing at, and we're going to pop them up. Okay, this is my I value, and this is my J value. You should have a worksheet that looks like this. Okay, so we have something that says J equals 1, and if we look, we can see that our J is at index 0, 1. Okay, so J is at 1. So my my I value is 4, and my J value is 6. So then we have a question, is J smaller than I? J is not smaller than I, so we're going to mark no. All right, so we'll take this back. Now, even if there is no, even if J is not less than I, we're still going to take I and move it to temp. All right. Then we'll record in our paper that temp is now 4, and our J value is 6. You'll notice that we started with 4 and 6, and we end with 4 and 6, and the reason for that is that there was no change. Nothing had to be swapped. So no change in the array translates to no change on our paper. We're going to pop I back into min index, and then this guy moves down, and we go to the next one. So 7. Once again, 4 is our I, and 7 is our J. So we're going to write that. 4 is I, 7 is J. And we're going to ask, hey, is 7 less than 4? Is J less than I? No. Okay. We're still going to take I and pop it down into the temp. And we can make note of what J is right now as well. J is 7. So our temp value is 4, and our J value is 7. Again, there is no switching happening, so there is no change between the initial values and the final values. All right, so then we're going to pop this back up here to min index. J moves over, and now we compare 4 and 3. So remember, min index is the smallest value that we have seen so far. So we're going to see what our I value is. I is 4, J is 3. So we're going to write 4 and 3. And now we ask, is J smaller than I? Well, in this case, yes, 3 is smaller than 4. All right. And now we get to see why we use the temp value. So we, as humans, could just do this. We could just swap them. However, a computer can't do that. What a computer would do, it would say, hey, J is less than 4, so I'm gonna make sure that the value at J, which is 3, is the smallest value we've seen so far, so I'm going to put it in min index. The problem with that is, can you see the 4 anymore? No. The 4 has been overwritten by the 3, and now we have a blank space, and the 4 is forever gone. The computer has written over it. So what we do instead is we say, hey, is J less than I? Yes. Cool. I pops down to temp. J right now is the smallest value we found, so we're going to assign it to min index. Okay? And now we can say, hey, temp is 4. And and then we take our temp and place it where J was. All right? Now at min index, we have the smallest value that we have seen so far. So then we're going to move over, pop this up. I is 3, J is 2. So I is 3, J is 2. Is J smaller than I? Yes. So we're going to take I, stored in temp. J is now the smallest value that we have seen so far, so we're going to assign it to min index. And then our temp gets assigned to J. All right, so now our smallest value of 2 is there. So our temp was 3. No, I'm sorry. Yes, our temp was 3. And our J value is also 3. So now J moves out again. We have 2 and 5. I is 2, J is 5. I is 2, J is 5. Is 5 smaller than 2? Is J smaller than I? No. I comes down to temp. So that gives us a temp value of 2 and a J value of 5. Temp value of 2, J value of 5. Pop this back up to min index because it's the smallest value that we've seen so far. And then we move over to the last index of the array as it is now, which is 1. So I is 2, J is 1. I is 2, J is 1. Now I ask, is J smaller than I? Is 1 smaller than 2? Yes. We're going to store 2 in temp. I gets reassigned to min index, and then 2 becomes J. So our temp was 2, and our J value, was also 2. So now we have successfully sorted the first index of our list. That's a lot, but the good news is we get shorter. We shorten our list. So J, if it moves over, it reaches the false of its for loop. So the for loop for J is while J is less than the length. If it moves over here, it's outside the length. So that triggers false, and our for loop increments by 1. Our for loop for the I and the min index increments 1. We go up here. Because it's a new incrementation, it's also a new J loop, so it gets right here. The relation between I and J is that I is at position I, while J is at I plus 1 whenever they start. So we'll do the next table together, and then I'll turn you loose. So we'll pop up 6 and 7. 6 is I, 7 is J. So 6 and 7. Is J smaller than I? No. Again, we're going to model the computer's behavior, bring the 6 down to temp, and so our temp is 6 and our J is 7. Oh, I wrote that in the wrong spot. Our 6 is temp and our J is 7. Okay. And then we move on to the next one. Bring this back up. Move on to increment our J. So now j is looking at 4. So we have 6 and 4 for I and j. 6 and 4. Is j less than I? Yes. So we're going to store I in the temporary index. We're going to assign j to the min index. So our temp is 6, and our new j will also be 6. As you go, try to identify the pattern, what's happening with these numbers whenever it's yes versus whenever it's no. All right, so now j is at the 4th position, so we're going to pop that up, 0, 1, 2, 3, 4. All right, so our I is 4 and our j is 3. So I is 4, j is 3. Is j smaller than I? Yes. I will get stored in the temp. J will get reassigned to min index. Our temp is 4, and our new j is 4 as well. 4 and 4. Okay, so now we move up again. We're looking at I is 3 and j is 5. I is 3, j is 5. Is j smaller than I? No. Again, 3 comes into the temp, and then we can just put it back. So temp is 3, j is 5. Temp is 3, j is 5. All right, then for our last value, we're going to move over, bring this down, bring this up. We have I is 3 and j is 2. So I is 3, j is 2. Is j smaller than I? Yes. So we're going to store I in the temporary storage, reassign j to the min index, and then put temp as j. And what we'll see is that we have sorted 1 and 2. Look at that. So let's see. We had 3 and 3 for our temp and our j value. And then because our j value breaks its true condition, our I loop increments up, our j loop resets to I plus 1. And then you just keep going like that. And that's it. So there's this page, and then on the back there's a few more, and then some questions. All right, that's the assignment.